Welcome, I'm Bill Wake. We're here working together on a calculator that can handle yards, feet, and inches, as well as just plain numbers. And we're to the point we want to work on negation. All right, now we left off yesterday. We were introducing a binary operator and making our operations kind of all come under that same flag. And I realized this morning, like, wait a minute, that's not going to work with negation. So I'm going to kind of move negation up. We'll do still a little cleanup here, but we're going to make sure we get this right before we go into this stage of replacing operations. Okay, let's get this going. There we are. So I guess we'll take a look at, I guess that's expression that was doing that. Yeah, so I don't know if anybody creates a binary yet. Okay, there's cases. Okay, I don't think we started using it. My thought was we would turn all these into a binary with an operator attached. And now I realize, like, oh, wait a minute. Our negation is actually kind of complicated. Let's see, where will that be? I guess it's in calculator. Okay, so right now when we see an operator, we basically try and override it if the last thing was an operator. So if you say 7 plus times 3, we turn that into 7 times 3. And the remove last just removes that last operator. But negation, we don't want to do that, because if you say 7 plus minus 3, that's actually legitimate with that. Now, I hadn't really quite decided. All right, let's run. Maybe we'll just do the unary operator and it'll all work out. We'll try it that way. Most calculators, you don't use minus as a unary minus. It has, instead of a prefix minus, it usually has a postfix negate thing, plus or minus. So you would say 77 plus or minus plus 3 equals, well, notice it didn't do anything about the plus or minus, but I think we could do that. It's going to look a little weirder, like 7 feet 8 inches plus or minus is really minus 7 feet minus 8 inches. This gets treated like a single operand. Let's try doing that first. I think that'll be okay. It's pretty common for calculators, and I suspect it's not all that used, but once in a while you need it. All right, so let's see if we can make this the priority. Now, the other place, where's that evaluated? Yeah. Okay, so when you're evaluating it, and subtracting all those, okay, they're binary operations. And they evaluate. Well, we're going to have to see how we think about these. Okay, but let's get this plus or minus key in there first. Okay, so in keypad, so we got to start at the user interface level. We'll start. We have a plus or minus key somewhere down in the last row. Okay, there's key plus or minus. It has no operator. All right, so let's look at entry. Now, we do want to eliminate this. Let's see if we can do that. This is really kind of a binary operator. It assumes it's got 2 values to work with. I don't know if it will pay to, I mean, we could say just pass the same argument twice and let it go. I think we'll try that. Okay, so first let's see if we can get rid of make. I think that was a refactoring we started down. Okay, Operator.make. Entry. Okay, now the entry
Oops, operator. This one hard codes that, but really add in these guys, I think we've modified them to take, oh, we did not. Maybe I started to. So yeah, the question is, how do you get from the key add, which is kind of this, the entry, into the actual operation, operator. Okay, so now, I'm backing off what I did. Okay, we got add with an operator. Is that, wait a minute, add, oh, we did put them in. Okay, okay. Yeah, so keep sorry, operator, this make entry. I think for all of these, we could say, well, dot. No, I guess we're going to have to. Here's the call. We have, oh, yeah, this is what we tried before. We wanted to say let the operator. Now it complained. I don't know if there is a way around this or not. Yeah. The operator must be bound in every pattern. Cannot find it in scope. Okay, well, I guess let's take that out. I don't think that's going to solve it now. Interesting, it's different messages. The operator must be bound in every pattern. I mean, it is. Okay. I don't know what the deal is there. That's what I want. Okay. Yeah, but see, he's got it left off, but we've got it in all of them. Yeah, that's fine. I can split it. How annoying. Okay, I think, do we have a way to ask for the operator? Okay, this is probably us. Is this a bug in Swift? First, second. Oh, okay. That seems legit. A little weird. Okay. Yeah, this is. I mean, it's very flexible, but I'm not sure why it's got a problem because each of these. Each of these operators needs the same value. Let me change that search. Whoops. Okay. If case, okay. Yeah, I'm not getting any. That's what we're trying to do. Cases include value bindings. All the patterns have to include the same set of value bindings. Each binding has to get a value from the same type from all the patterns in the compound case. I don't understand. Try to omit one in the compound example. We're given an explanatory message. Well, yeah, that's understandable. It's not looking good here. Not at all. Okay. Yeah. So, what do I have to do to... Okay. I guess I can give an operator method on entry. Let's see that. We have is operator. Okay, so I'm going to try and pull some of the case stuff out. I don't think that should matter. Let's see, operator. Which one was I working on? Jeez. Entry. Expression. Okay, we'll try it though. Because putting the let in front is supposed to be the equivalent, but maybe it's not a true equivalent. And we'll take that. Huh, mail. It's slightly. Oh, you're right. Cool. Okay. How weird. I thought for sure it would warn me, like, oh, you should pull the let out. Okay, so now we're not calling make because we know the operator. It's attached. Okay. And this should be equivalent. Great. Okay. Now, entry may, no, operator make is no longer used. All right, so that's at least a step towards what we wanted. Okay, so now, let's get our, let's see, where do we want to test this? Okay, I think in expression, I think this one, well, no, we may be able to get there yet. All right, let's get the plus or minus working. So we'll make an outside test on this, or maybe a calculator test. Okay. On number. Is it a new thing? Enter. Well, it's not a binary op. Entry.add. Well, that should be multiply. Okay. Let's say unary op. And I don't think they're not going to have precedence in the same way the other ones do, that we just automatically apply them. Or you could think of it as the highest precedence, but I don't even think it is. Does our algorithm going to care? I'm not sure what will happen on the evaluation side. So we'll create it as another operator, I guess, and see what we get going. No, you normally type 7 and then the plus or minus key, say. So after an operand is in place. Okay, and then the function is, well, you take A, B in, and we're going to return minus A. Okay, now I'm going to make this a binary op for the moment. Binary. And then operator. Name plus or minus. Notice we don't care what the name is. 99. And then this function. This looks too goofy to me. Operator and that. Enter equals, and then I guess we expect minus 7. Okay, so 7 plus or minus equals should be minus 7. It's just really... oh, it is values. I think we gave it a negate. Okay. Right. Should fail. Yeah, we don't want a binary op. Huh. What? And I guess it's legit that this should be ignored. Why did that work? Because something's fishy. Expression, it's going to push any values that are pending. Clear out pending, okay. Then it evaluates at least precedence. And it pushes the operator. Okay, so it pushes. Wait a minute. Okay, so according to that, this should work. 7 plus or minus, oh, it's not attached. Okay, equals. All right. I'm puzzled. Okay, so evaluate at least the precedence, right? That's top has to be greater than ours. It's the highest precedence, so this does not get executed. And it just pushes the operator on the stack. But when do we apply it? This is weird. Evaluate at least 0, then we apply it. I feel like it's. My intuition is it should bust the stack, and I'm not sure why it's not. We don't start with anything on it. Okay, at the end we evaluate at least 0. It pushes value up parse pending. All right, I want to stop in our code and okay, let's say print a print return. I'm going to print a equals and print them both and return the negation. Yeah, I just don't like not trusting it. All right. Let me just run the one test. No value found. Okay, we made our stack produce that error if there's nothing in it. All right, yeah, I'd kind of forgotten that. Stack, pop, element remove last. I don't know, where's that no error found coming from? What text? If numbers is empty. Parse. Okay. So it's acting weird. Let's. Let's extend the test a little. I just got my head up. So I'm saying 7 plus 6 plus or minus. I should get a 1 out of the whole thing. I've still got that print in there. That's okay. Yeah, so it passes because this is not really a binary operation. It really is only calculating on the first one. So in effect, it's popping that extra value, but it just doesn't, it doesn't have any effect. It's ignoring it anyway. So in a way, it's harmless, but in a way, like a unary operator should only pop one item. So I think I think I want to make this different, and we'll we'll make this happen. -6. Okay. So I'm going to make a unary operator. It only gets one argument. Oh, man. Is this... No, I think I still need the 2 arguments, but I want to evaluate this differently. Okay, so unary doesn't exist. That's entry. Okay, so let's add unary. Okay, now people should be complaining. Okay, there's unary on enter. What does op do? Removes that. Okay, we don't want to do that part. So let's do unary op of entry. And I'm going to change this to binary. Okay. Now, is that wrong? All right, once unary. Unary op. Okay. So if you have an operator, I mean that is a bad case. So you say 7 plus or minus. It's a postfix operator, so that really maybe should remove that. I guess I could have got by with op. Okay. Description. Should be the same. All right, let's try that again. Okay, what does it get? 6. All right. Yeah, now I think our expression evaluation default just breaks, so it doesn't handle it. All right, so let's say case unary, and these, I think we're going to rely on the fact that we're just always going to evaluate them. So I think we won't pop the stack. All right. But we're going to call evaluate. Okay, so we're doing a little bit of this, but just once. Well, let's make an evaluate unary. Evaluate unary. We don't need a precedence. Okay. We're going to pop the top. We're going to pop the operand. And we're going to evaluate A with A. Because so far we're treating it as Well, we're treating it as only an error. Well, what's your problem? Oh. Okay. Hey, unary, good. Okay, let the operator. Well, that's okay. Evaluate unary. Okay, and then push the operator? No, we've evaluated it. Okay. Oh, that's a problem. The operator we need. We're going to pop the operator. Okay. Input equals. Sorry, we push the operand, and then I guess we need to, well, let's just pass the operator instead. We have not pushed it on the operator stack, and we don't intend to. Push unary op.evaluate. Okay, so evaluate a unary operator, you just take the top operand and then push the result. I think that's right. Apparently not. Okay. No value found. All right, let's just run this one. Okay, what did you print though? Number six. Okay, let's walk through. What's our code test now? Is it 6? Oh, just 6 plus or minus. Okay. So I'm going to walk through here. Okay, so this should be digit, right? And then entry is unary op. All right, let's look at operands. Nothing in this stack. Okay, so we've got pending is 6. Right, we'll push the value pending. Okay, this should have that value now. All right, we'll step in. Step over. Oh, man. Unary op.evaluate. Well, let's break here again. Okay, so skip this one. All right, now we have a unary op. We'll continue. Okay. So the operand stack should look right. If we print unary op dot evaluate AA. Ooh. A equals 0, B equals 0. Let's see what A is. It should be number 6. Whoops. Value error. Sorry, I'm being dense here. Okay, we'll continue. Continue. Step over, and now we should be able to print A. Should be 6. Okay. Print unary op, it should be our plus or minus thing. Okay. And it should ignore. If I say unary op dot evaluate AA, should be number 6. Okay, let's print operand should be empty. Step over. Now operand should have number -6. Wait a minute. Oh, number -6. Yes, that should be there now. Okay. Let's go out. Okay. Entry is done. Okay. This seems wrong. Okay. So if you just type 37 and you get down here, you had no operators, then your digits got evaluated. You push in there. It's supposed to be digit. No, I think this is the case where you're actually done typing and you got your last operand. I think this is the first time we've had a possibility that the final character wasn't part of an operand, so you always needed to, previously you needed to push pending every time when you got all the way through. So if all you type is 37 and then equals, you get the 30, the 7, they both accumulate in pending, and then you need to create the value and push it, and then that final evaluation that enter does, okay? But here we've already evaluated. So I think that the reality is the only time we would evaluate this is if we have pending stuff. Okay, so if, well, now, is this right? I don't know what happens if you say 3 plus. We'll have to see if we detect that. But let's see, if pending dot is empty, not empty, but not empty, then we want to push. If it is empty, it means it was already pushed and we don't need to do anything. Okay, but one way or the other, there should be a value when you get here. Okay, so I believe this will fix that. Right. Take out these breakpoints. Let's just take them all out. Okay, continue. Right. And now if we run just this test, I believe we will see that we are not popping two values like we were before. We print the same value twice. So we don't really want these prints in here. We don't need return if it's the only value. Okay. Now, yeah, so in the case of multiple digits, if you hit evaluate, you'll basically reproduce the input. So if you say 37 plus or minus, I mean, actually, let's do this instead of me talking and trying to convince myself. I mean, I'm pretty convinced, but let's make sure it's a good question. Okay, so yeah, because in that loop, it just pushes the digits on the pen. Well, it appends them to the pending stuff. So digits accumulate, and then normally at that point, you're either going to type an operator plus 64 plus, okay, then push that on the stack, and that's the first thing that happens in binary. Or you're going to hit equals, which is entry. Well, you're just going to skip, I guess. And that'll be the end of the thing. And then pending is not empty because you haven't done anything with this value. And so you push it and then evaluate and pop it. And that's the result of the computation. Yeah, so I don't think there's an issue there. The only... Is that really... Okay. Now, I think the evaluation... Well... I was going to say, can I make an error there? Because that would actually be more likely to trigger something. Okay, that shouldn't trigger. I mean, maybe I could just say unary up second argument. Yeah, no, I think this is okay. All right. But somewhere we do some stuff to see like, oh, if you're combining this value with an error, then it's an error. So I'm not sure this will break that. No? Okay. Let's go to value. Well, the next test is inches. All right, but plus, I am a little confused because we do say if it's an error, return it. Okay. Let's do this with units. That's a good question too. Let's do that. It should be an error. Whether it will be, I don't know. Okay, because he's not a binary operator. Plus or minus. How about in wrong place? Okay, and I think this should be some sort of error. Plus or minus 6 plus or minus, that should be fine. Then the 4, yeah, I'm not sure we enforce these quite right, but that's why we're running it. Okay. Yeah, so that's right. So what's happening is the 6 gets appended,
the plus or minus parses it and parses that 6 and pushes it on the stack, then the unary operator comes in and negates it, so it's -6 on the stack. Yeah, there's okay. I think the problem is when you finish this thing, the stack should be empty, and if it's not, then there's a problem. So yeah, we're driving this out. If operands dot count not equal 1, then we're going to return error. I don't know. I learned to say it like this. Count has no member count, really. Operands is stack. Well, they're right. Okay, and this should just be a message issue. Right. Okay, let's get a better message. What's the error? Let's see. The error is well, it's kind of like missing operators or something, but it's is it missing? Operators missing between values. Maybe that's the right way to say it. So normally, up until now, you couldn't have this problem, I don't think, because you would type 6, 4, 1, 3, 7. The next thing you typed had to be an operator. So you're just accumulating stuff. Once you type an operator, we push your value on the list and push an operator. So we would never end up with operands with no corresponding operators. But now, because you've pushed it, you push the operator and evaluate it. Whoops, where's my unary? You push the operator and evaluate. You've just pushed a value. No operator is required to complete the pending anymore. And which I don't really like the way we're doing pending, but I don't know. Is it possible to pop the unary op and push it back after adding a digit? Yeah, that's an interesting way to look at it. Okay, evaluate kicks in here. Calculator is the guy controlling that. Enter. So yeah, so I think what you're saying is if we do digit and then unary op, right? Those are just added to the list. Yeah, because I mean this process we're doing is a two-phase process because we gather the whole input and then we evaluate it. So calculator is gathering it, and he does stuff like this to enforce that
the expression stays valid. So if all right, and then expression is operating on entries, right? So the number is already interpreted there, so it has to be done in calculator if it's going to happen. So digit entry, and I think that's just appending. Yeah, I think what you're saying is if the previous one is an operator, there's no problem. But if it was a unary op, then you haven't put an operator. Okay. Yeah, let's make that. Okay, so that would take this error out. Yeah, so it makes it not, if you've formed your expression correctly, this should never happen. It's almost it should be more like a fatal error. It's not something that should happen. And I think the way we're doing it, we're enforcing that here. And so I think what you're saying is this should be negative 64. Okay. So plus or minus, how about digit after unary op is placed before it. Okay, so if I type 6 unary 4, it's going to slide it over and make that 6-4 unary and evaluate it as 64. Okay, that seems good. Okay, enter unit. Let's take a look at that too. Okay, we'll deal with units too, but let's get this straight first. Okay, so if the last let's see our input buffer. Okay, I guess if not empty and last is a unary op, we're going to swap around. Okay. Right. So if we call it buffer input dot is empty, which I almost never want to know. I always want to know if it's not empty. And input dot last. Well, I want to say this, but that doesn't really work because it wants the operator there. Okay, let's try another. I guess I can do if let. I think I can say the same thing. If input is not empty, comma, unary op equals input dot last. Expected let and conditional insert let. Okay. If the input is not empty and oh man. Oh. Go. Oh gosh. Input last is an entry. I want to ask it, what's your operator? Well, let's say we knew this thing. All right, somehow unary op, we're going to say input dot remove last if well, at this point I'm saying true. Do I have a last if? A last? No. Okay. Okay, so always remove it. And then I guess that's enough. And then we're kind of pairing it with symmetry. If well, if the unary op is not nil, then input.add unary op. I'm going to say dot op. Okay, and that's going to be an optional value. All right, so input buffer, no, entry op. His type is operator optional. His value is switch self default is nil. And then these cases, case dot add okay, so I'm saying you should be able to see, you should be able to get that value out. All right, now this should be happier. Oh, it only holds in that scope. Okay, let's try this. Let unary op equal input dot last. Oh no, he doesn't do that. Golly. Well, maybe that's all right. Type of this should be operator question mark. Good. Cannot convert operator to expected argument type. Oh, we need the okay, let previous equal add digit and add unary and block else just add digit. Yeah, maybe that'd be better. Okay, so we're trying to get to the last input is empty, goes to nil, otherwise it's input dot last. Okay, this is previous entry. Okay, now if this is previous entry question mark dot op, so it's nullable if okay, if the previous entry here, okay, I want to push previous entry. Okay, so all right, I'm still okay. I've got the previous entry. I've got its operator. Both are nil if they're not valid. Okay, so I want to say, oh no, I need to know. I think I'm answering the wrong question. I need to know if it's a unary op. We don't have that question on entry. Okay, let's make this is binary operator. Okay, and then his unary operator. Actually, these would probably be better as variables, wouldn't they? It's kind of a characteristic. No, I can do this better too. No. Okay. Is a Boolean? All right. Let's go back here. So the question is, if something well, if previous entry dot is unary operator. Okay. Maybe that's where I'm going wrong. Okay. If the previous entry and let's do what you suggested. Basically make the two branches totally separate. Otherwise, just do the digit. Okay, now see if we can get this straight. Okay, if previous entry is not nil and it is a unary operator, then remove it, add the digit, and put that previous entry back in. Otherwise, the previous entry is either nil, meaning we're empty, or it's not a unary operator, then we're just going to push the digit. Ugh. Ugly, but I think it's right. Now, where's your complaints here? Yeah. Okay, and now is anybody looking at op? I don't think so. Nope. So op is a waste. Okay. Now, I think. Now, I feel like there should be a way to write this directly. If case. Now, if I do case let, I'm assigning it to. Okay, if case let unary equals self. Return true, otherwise return false. That should be the equivalent. Right. If case unary equals self, so if we are a unary operator, then return true. That should be fine. Okay, so add plus or minus, working for integer for numbers, and make plus or minus move past digits if trying to treat it as an operator. As a binary operator. Okay. Right. Okay. This I'm going to make into a var as well. Compiler will tell me where. There were a couple. Oh, I do need a function. Okay. Well, okay. Right, but I can still use this. Oh, it's easier with that, isn't it? Okay, we'll keep that for now. I don't know if I netted any change here. Our state machine is getting a little complicated in here. The good thing of this is we're dealing with stuff as it happens. The bad thing is that means we're keeping track of a bunch of little state possibilities, and I just don't know how I'm going to know we covered them all. All right, let's move on to another test. Okay, so I think that's all right. Okay, so this one, well, it's unit value, then binary op, unary op. Okay, so let's do 6 unit inch. We'll do plus or minus. Negate is fine. We'll skip that. Equals. And this should be minus 6 inches. 6 inch negated equals minus 6 inches. All right. And good. Check that units work with plus or minus. We can make it a little more tricky. Let's make it 13, and we should get minus 1 foot, minus 1 inch. Actually, I'd be happier if it were 1 yard as well. 1 yard, 13 inches should be minus 1 yard, minus 1 foot, minus 1 inch. Let's make this 24, 27, just so we get different values and make sure nothing's confused that way. 1 yard, 24, 3. Okay. And I think this should pass. And I think leave as complicated as one like this is enough. I don't feel like I have to keep the test that just starts with the simple pieces, seeing as they both just worked out of the box. All right, now I'm a deeper test for unit negation. All right, now I feel bad knowing this. We also have to worry about inches then. If somebody types 6 inches plus or minus, they've entered a value. And if they type 1 after that or inch after that, it really should, kind of by the same argument, slide over for that too. So let's make that one happen. I think it's closer to this. I just don't know if that's right from a usability point of view. You say 3 feet 2 inches plus or minus 7. You really want that 1 to become 1/7 and then slide over? 3 inch plus or minus 7 becomes 3 inch 7 plus or minus, so you still need a unit. I'm not sure we can tell. Yeah, that's true. Okay, then let's just document what happens. Digit after unary op on unit is placed, is left where it is. Six inches unary op 4. Now, this, I think, should give you an error, though. We're just not preventing it. So mostly what we've done with these is we've made them preventive, like the 6 plus times 3. It's a syntax error, except we just drop the plus and make it 6 times 3. This time we really do get an error, and I don't remember the message, so I'll just let it tell me. But I hope that that error comes in. Yeah, okay. Did that run? I don't believe it. Thank you. All right, if I get the other numbers and units don't match. Well, that's an interesting... Yeah, that is true. That's... Okay. I guess that's kind of what that error is. You're saying 6 inches 4 and units don't match. Okay, I can live with that. Okay, well, I'm happy it's robust then. Unary after a unit value. Reports error if followed by a number. Okay. Yeah, I think that's reasonable enough. I don't think we can prevent every possible error, but I think we can prevent some. All right. Now let's take a break, but I think we're going to come back and hook it up and see it just working. Let's hope. All right. So let's see you in 3 or 4 minutes. All right. Welcome back. Gosh, I'm still a little bugged by this test. I just want to fix this little tiny thing before we go. I did try deleting the test stuff. And I think it's because we deleted it while it was marked not valid. And I'm just going to try and do this. If the last input is neither a digit or a unit, should plus or minus do nothing or generate an error? Well, that's a good question. I think he should be an error. If you just type plus or minus, right, that's not legit, or plus, same kind of argument. Yeah, let's get this marked in. Calc 2311. Negation. All right, so we're doing that, and I think it's a very good. What about plus minus in first or after an operator? Okay, this I think we're kind of in the process of. I guess we're still doing this one. Let's put it first. All right. Yeah, so if you type plus or minus equals, that should be an error. If you type 7 plus or minus 3, I think that should be an error. I don't know if there's a way to make it come out right. It could be a confusion that you think plus or minus is a prefix operator, I guess. But I think we'll do it. Let's make a test for it. Okay, so this. Why is he enable? Delete. Okay. Let's see. So we're making up tell you what. Let's do that up at the system level. Content view tests. Okay. I forget what we did for plus or minus. Oh, squiggle. Okay. Start easy. 12 plus or minus equals, we expect minus 12. Yep, that fails. Okay. Our keypad, well, it needs an operator. Plus or minus. Okay, and this is unary. Operator name is plus or minus. Precedence is kind of arbitrary. And this is A, B, A ignore in A dot negate. Okay, it's the same function we used in our test. All right. And that should do it. All right, let's run. And then we'll try those test cases you suggested. First, I want to see it working. Plus or minus equals, okay. 1 foot 8 inches plus or minus 88 is 6 feet 72 84, so it's 2 yards 2 feet 4 inches negative. Yeah. Okay, I'm happy there. All right, let's clear. If I just do plus or minus equals, no value found. Good. Okay. Last input is neither a digit nor a unit. So 8 plus or minus. Oh, we treat it as an operator. I could see that. All right. Plus 3 equals error operator missing between values. Well, I don't know. If you watch me some days, it's like type, untype, type, untype. A lot of practice, I guess, over the time. Yeah. But, you know, like I said, I was expecting that to kind of work, and it doesn't. 2 plus or minus plus 3. So that should be minus 2 plus 3 equals 1, and we're definitely not getting it. So let's put that case in, maybe down here. Okay. Digit plus or minus add digit should negate and add. And I don't know, sometimes I don't often put the shoulds in there, but usually I want them so clear that's what should happen, or it to be obvious, but this one is not obvious, at least to me. Okay, 6 plus or minus, and then we want add. This was called add op. 6 So this should be 6 turned into -6 plus 4 equals should be -2. 2. Okay. 6. I don't know if this. Trying to decide where these tests belong. They're wordy at this level, but they're more direct. Xcode, man. Yeah. So, what we're doing is basically we're kind of enforcing the syntax as you go, and in a lot of the cases, we can sort of throw out things and make it look right. So if you say 7 plus times 3, when you say plus times, we immediately drop the plus because it was an operator preceded by an operator. So in up until today, when we added negation, you pretty much always had to have digits or units followed by operators, followed by more digits and units, followed by more operators. It always had to follow that pattern. Now we're getting messier because this plus or minus thing doesn't fit the pattern. But we did say if you do like 6 plus or minus 2, it's not really a binary operator. So we slid the 2 over so it looks like 62 plus or minus. And something in what we're doing with that is not stacking up right or something. Errors missing between values means we pushed 2 values without actually operating on them. And now we want to understand why. Okay, so, well, what we're getting is 6, so that should push the 6 into the pending. A unary operator, so we should turn the pending into a value and push it on the stack, so we get the actual 6. And then evaluate the unary. We pop that off the stack. That's kind of redundant, isn't it? We pop it off the stack and evaluate it and push it back on the stack. So that should be -6 at this point. And then the operand stack should be -6. The operator stack should be empty. We never put it on the stack because it's a unary. All right. Now we get a binary. We should push. Oh, we get another digit 4 and accumulate it and then push it when we get the plus. No, wait. Sorry. It was 6 plus or minus plus something. So 6 plus or minus, we did -6 on the operand stack. Operator stack is empty. Binary operator, we push any pending values. There is none. That's a problem. We kind of ran into this before. Oh, we're actually down here, but it's kind of like there is no pending at this point. All right. So I think the reason it's failing is in both these cases, it should, if not, pending is empty. And I kind of hate having these special cases, but I think they reflect what we need. Now we may be able to organize this more. Okay, so we're only going to push it if it's unprocessed. And in our case, we actually processed it when we got the unary op. No, it's pending is digits we've accumulated as input without any operations yet. So if it was 42 plus 7, we'd get 4, 2, and we'd see the plus and say, oh, I see you're done entering your operand. Let's push the values, form them into a value and push them. Okay. And up until now, that was always the case. You had, units or integers. And then when the operand came in, you had stuff there. You couldn't start with none because that wouldn't be legal. And that was fine. But now it's expecting the operator digits, say, to be pushed to be pending, and they're no longer pending because the unary already took care of it. So it's kind of I don't think we don't, yeah, I don't want to say this. There may be a way to flip this around that would be better. Normally, like, I guess I'd say my background's compilers, so writing parsers and scanners and stuff like that, it's very common to kind of have one token look ahead, and so you decide, what should I do? Well, then a digit would say, hey, I'm going to append, and if my next character is not a digit, then I should just take care of it and push the operand. And maybe we need to flip that around to do that, and it would avoid this stuff, because I feel like we're having to check more and more, and I don't really like that. Yeah, the other place we hit it was here. So if you did 7 plus or minus, 7 took care of the plus or minus. The plus or minus pushed the 7 on and then negated it -7 on the stack, but there's no more pending because the thing already took care of it. Unary does remove the pending, and it should, I think, because it's got to process that value. So it needs to gather all the characters into a number, 472, make a number, and then negate it to do its job. Now, I don't know that we have to push it and then pop it and then push it again, but I think we can inline that and improve it. But the problem from the binary end is this pending stuff it's no longer true that pending is going to be non-empty when you get in here. And now we're paying for it. So I don't know, maybe we should do that flip. It's let me make a note on that one, because it's not a quick one, but it would probably be a conceptual win that you're not thinking about, because the way it is now, like when I'm doing operator, I have to think about what was the last operand, and I take care of it. And same on the operand, I look and say, oh, was the previous thing an operator? I could take care of that too. And they just kind of are in each other's business. But I think we can flip that. So make, evaluate, use one item look ahead, and I'll give it question marks. We may just try and experiment and see if we can do that, but I think we'll do it outside this. All right, so now I'm enforcing that the pending might not be empty everywhere we evaluate it. Okay, so this almost is a little routine or something at this point, but the flipped version will make sure pending is dealt with before it leaves digit or unit. Okay, so we'll see. All right, but I do think this should pass our test now. And I want one more test. Okay, because this one you raised as well, sort of implicitly maybe, but this case of just plus or minus first is error. Okay, so we enter our unary operator, and equals, we'll get an error, and I'm going to be lazy and let it tell me the error, assuming it finds it. I think no value found. Okay, so I think that documents the other case we're worried about. Okay. Let's run it one more time. Okay, so 44 plus or minus plus 45 minus 44 plus or minus looks a little weird. So that's negative 44 plus 45 is 1, plus 44 is 45. Yeah. All right. 5 times 3 plus or minus should be negative 15. Okay. I'm kind of good there. All right. So handle situations where plus or minus is first, or what was the other case we did? Oh, yeah, it was operators or regular binary operators following plus or minus. Okay, good. Okay, so I think my fear of expression, this binary thing, versus the separate operators, I'm pretty sure nothing we did there dealt with that. Now, what I want to do is get rid of add, subtract, multiply, and divide and just use binary operator. Okay. I think we've left the code parallel and consistent, pending evaluate at least operator precedence coming in. Okay. So let's find people who use this. Okay, calculator. Binary does op entry. Okay. Add op equals entry dot add. Let's make this entry dot binary. And entry dot binary. Okay, that should pass. Okay, there you have it. Oh, I guess it's not consistent. What test is this? Last operator wins. Right, I have to make all these handle of cases first, I guess. Okay. Case add, right? That one's okay. This one, right, binary did not return true. Binary. Add, subtract. Oh, who should be? Nobody uses that. Okay. I'll comment it for now just in case Xcode's a little flaky, but whoops. Let's keep looking. That's that one, this one, add. Okay, the operator.name, keypad.add. That's actually should be using operator.name as well. Okay. Let the operator, this one we checked. Key.add. Let's see if the calculator tests are working now. Okay, so now our keypad, these should be binary. Slash. Unary. Okay. Okay, make all uses of add, subtract, multiply, or divide. Use dot binary now. Okay, and so now entry should not need these. And there should be lots of compiler complaints. Like, who are you? Okay. Let's make this one work like this one. If case binary, self return true, otherwise return false. Okay. Nothing blew up because that wasn't there. Add, subtract, multiply, and divide. Calculator. Subtract, multiply, divide. We got binary above it. And this case. Good. Okay. Well, that's a nice move in the sense of what's going on for evaluate. We've delegated the work to the operator, and I think that's an improvement. All right, so what we've done, remove remnants of add, subtract. Yeah, I think it's nice. The place we would get burnt is if we did do our subtraction with subtraction meaning both negation or minus, so it's unary and binary. That really does screw up the grammar and makes it hard to know. Like we don't have a way to tell which one's the subtract operator. We just know we're taking an operator and applying it. So we'd have to have some sort of special case or a flag or something to tell the operator like, oh, you're really a binary and unary operator, and be careful. Okay. But we're kind of punting that one away and using the plus or minus key. And I'm sure that's why the plus or minus key got put on calculators, because nobody likes to parse that leading unary minus. Okay. I think we got 45 minutes. All right. So this is good. Yeah, we did both those. Okay. I'll say error for plus or minus is after an operator. Okay. That we've done. All right. Make evaluate use one. Okay. We replace these with binary, and we removed Operator.make. Okay, I guess we did that before. We actually did this one first. Input negative numbers. We made a decision there. Oh, yeah, that's a good question. Thank you. Test plus or minus with 0. And I think it should be okay, although they do have negative 0, but I think it will just write a 0. Well, let's see. Content view test. Okay. 0 plus or minus equals expect 0. And then this one, 0 inches equals 0 inches plus or minus equals, I guess, equals expect. I guess I expect 0 inches out of that. I don't think we ever convert from inches back to there, but 0 is a funny one because like 0 feet equal to 0 inches. Well, yes, it kind of is, 0 is kind of a nothing value. All right. But we would like both these to pass. Okay. What are we getting? Are we getting -0? Huh. Now this is... Yeah, like I said, doubles do have -0 is the value for them. I don't know why they chose to do that way. You don't get that for integers, right? But I'll go back to IEEE floating point standard, but I'm pretty sure it's saying actually the Wikipedia page is probably better to go to. Wikipedia. Yeah. Yeah, so they do have signed zeros in that. I don't think it hurts anything. And I don't feel compelled to turn it into a positive 0. I mean, 0 just is 0. We can check that too while we're checking zeros. 0 equals, I expect that one to just be plain old 0. If you start entering decimals, I mean, if you're having decimal points and stuff, yeah, I mean, I don't know what happens. If you do -0 plus some decimals, it'll turn into, -0 plus 0.0001 is going to be close to 0.001. Probably won't be exact because of not being a binary value, but yeah, I mean, I think in most cases, -0 gets treated as 0. I think it's more a representational thing. I don't know what happens. I mean, I guess we could just do a generic test in here real quick. Play around a little. Zeros. -0, 1, 2, 3. But I think if I add, how do I get a -0? I don't know if it'll, what Swift will do. Okay, let's just print -0. Print -0 plus 0.123, and then I don't know what's a case that would be funny. Well, let's start there. I mean, I don't know if Swift will make that a -0, if it'll optimize it into a 0. It will. Okay. Interesting. Okay. -7 plus 7, is that a -0? I don't think it's gonna be. Okay, let's put a Swift question out there. -0. It's weird because we're seeing it, so we know it can happen. We've done it. Maybe print is more forgiving. Yeah. Let's do this. -0. Like that. No. Yeah. We don't have decimals yet, so in a way it's not a problem for us. Decimals would be a good thing to add. But I think it's odd, but like I don't know how we. Okay, let's see if there's a way to. Oh, there's a negate. Oh. Gate. Cannot use mutating. Okay. I don't know if this is. Oh. I don't know if this will get us that value or not. Okay. 0. Yeah, I don't know how we can generate a -0. We clearly do. And the arithmetic is being done as a double, so I don't know what we've done differently that unfortunately with a double. Oh, yeah, I didn't make it doubles. Okay, let's go back. Oh, yeah, I totally didn't. Okay. Okay. No. Okay, I don't know. But they're there. I mean, this person saw them. The value is 0. Get -0. All right, let's take this. Okay, that prints 10. Let's make this -0.0. Okay, let's print A and B. Comma's wrong. No, it didn't run. What's going on? Execute 0 tests. Func test. I don't think the case should matter. 1 test. Okay, finally. Hey, there it is. Okay, so we can get it. It's just uncommon. All right, well, interesting to know. I mean, I don't think I've ever run into it in real use. But, okay. All right, we got half an hour. I would like to try our parentheses. Okay. And I feel like that should be like really straightforward. Do we have an entry for it? We don't. Okay, I don't know. Sometimes we start at the front end, and sometimes we start in the back end. Excuse me. Let's start 2 + 1 times 3. And we expect 3 times 3 is 9. Okay, so well, right now we don't have a left parenthesis. Okay. Okay, so I think we'll get a message from this one because our key isn't there. But that should be a legitimate expression. All right, let's dig in. Now, these things are vulnerable to errors too. Yeah, we get a couple DVDs. I don't know. Let's run this one test. Okay, 5 is not equal to 9. I don't know why. I guess we're getting TBD because it's a default keypad. All right, keypad. Well, left paren. And they get treated differently, so I'm going to treat them differently. Left parens get pushed on the stack, right parens consume them. So entry. All right, and they have nothing to them. And then we should have some complaints. Switch must be exhaustive. Okay. That's that one. Okay. Case left. Case right parent. Okay, well, maybe this is too easy. If you do 3 plus parentheses, I mean, I think we already pushed the operator on the stack, right? So, yeah, it just adds that to the stack. So we don't have to worry about that. A left parent. Yeah, I think we just need to input.add entry. And same thing for right parent. Well, we'll do that, but I think there's more work that has to happen. Entry. Okay. So I don't know how far I'm going to push this in. We should get rid of our TBDs. Oh, we're still... Okay. Entry description. Okay, that's easy. Okay. Yeah, so the left one has high precedence. We may have to make them operators. The right one, though, it doesn't really need precedence because it's just consuming. You know, you don't. It's backing up until it hits a left parend and kind of consumes that, but it doesn't.
it doesn't say, oh, I should wait for, is your operator higher precedence than me? It just sort of assumes it's the high precedence. Like I should just keep going. I'm higher than all you guys. Now our plus or minus, maybe I made it 99 is probably a bit much, but okay. So that should build. It should get rid of our TBDs, but it will not work. Or at least if it does, it's dumb luck. Yeah. Okay. And the message value is 5. I don't know where 5 comes from. All right. So I think what we want to say is, well, it's in this expression stuff. So far, all we've done is we just pushed it. We just passed it along in calculator. It just says, that's part of the expression. Keep going and handle it. All right. Now in interpreting it. All right. Well, I guess we just had to do the cases, right? Put break for now, and this one, I believe we have to do this. Do I need that for our purposes? I don't think I do. We're going to have to, but operators.push. I guess he is an operator. Name 0, precedence. Oh, thank you. That's a good question. It kind of is, but I mean, it's unary in effect, but it's not a unary operator. I don't even know why. Well, what's going on here? Name empty. In effect, it's precedence. And if you have a right parend and a star comes in, you're pushing values. Well, I don't even know if this matters. Let's just give it a number. I'm just going to give it high. And then evaluate. It's never going to evaluate. We'll just return whatever it gets passed. It doesn't fit great. And it's almost enough to make me wonder if we should be pushing entries and not operators. But I guess if we can get it to act right, it's okay. So if you get a parenthesis, push it on the stack. All right. And then at the right parend, okay, let's just take this and see. It shouldn't work. I want to make sure it doesn't. I don't know what it'll be. Okay. Which test is this? Test. Is there a way to turn off system ones? Calculations. Okay, so tab blew up.
Oh, because tap does not know left parenthesis. Okay. Well, no, that should just work here. Key set with the key name. Yeah, so he should just be pressing a left parent. Why are you blowing up? I guess it's blowing up on this line because that's the others all worked. Tap input. Well, we should see key. Find button. We found the button. I mean, it should be doing the calculator stuff. Let's check. Okay, content view. Okay, so that's adding the left parenthesis, that's adding the right parenthesis, and then somewhere after that. Okay, and then pop, evaluate at least. Okay, yeah. Okay, why is that? Yeah, is that what it's doing? It's popping the binary paren. Evaluate at least says if the operator stack is greater than or equal to precedence, then you should apply it. So maybe I got to go the other way on the precedence of it. I mean, I think it should just fall out. So I'm hoping that's the case. Left paren. Sorry, calculator. Where's our push? Is it evaluate? All right. It's an expression. So our push, there we are. Let's make this 0. Yeah, I don't think it's going to work like unary either, though. I mean, it should just push on the stack, evaluate stuff. Yeah, maybe I don't know what I'm doing as well as I had hoped. Okay, so I just want to push this thing on the stack. That seems reasonable to me. So you come in parend 3 plus 2. All right, the plus is going to say evaluate at least. And while the top is higher, it's not, it's lower. Okay, so, well, it's, yeah, I mean, it kind of is that. All right, let's skip these. No. Oh, it may be that because I'm not handling my right parenthesis. Okay, let's If I say evaluate at least 0, is that going to do it? So you push that thing and you get your plus on there. Then you get your right parend. We want to evaluate the plus and pop this. Okay, so I think we want to evaluate at least 1. Well, I think we got to do this, which I'm coming to hate. All right, but if you said 3 plus 2, you've got a pending operator, so you have to take care of that. Then I'm going to say evaluate at least, well, I don't want to pop my 0 up, so I'm going to say 1. And then I should have left parend on top of stack. And then if, how can I get the name? Well, I should just pop, okay. Operators dot pop. Okay. I think I'm kind of feeling my way into this, but it should be there. Now we haven't dealt with what if you forget to type your left parend. Okay, let's see if this is getting us closer. Yeah. Okay. Right. So this, let's see. All right. I think I'm doing it correctly. Push a left parend always. When you get the right parend, evaluate everything back within the parenthesis, within the nearest nested parenthesis, right? That feels right. And then you should have a left parend on top and catch the error. Okay. Well, I'm sorry, and pop it off and you're done and move on to the rest of the expressions. All right. I need a new test case. I want to do some complex ones and make sure this is doing it right. I mean, this is pretty good. All right, but let's do something. Let's keep going. 3 minus 1. Okay, is 3 times 2 is 6. Okay, and then I want some nested parentheses. Times 3 times 4. Oh, you're not gonna. Plus 2. 1, 2, 3, 4. 1, 2, 3, 4. Okay, 3 times 4 is 12. Plus 2 is 14. Times 2 is 28. Okay. Yeah, is it? I don't know. I'm very used to doing it in a big single stack, honestly. But it would be possible to kind of create a new stack for these things, and then the right parend kind of pops that stack. All right. My hope and expectation is these all work. Let's do a couple unit ones, because I think they come for free, basically, if we're doing things right. How about 11 inches plus 1 inch times 3 is 30. well, this is 12 inches. That's 3 feet. So we should get a yard out. "11 inches plus 1 inch is 12 inches times 3 is 3 feet, 3 yards, 1 yard." Okay. And then I think 7 inches plus 11 inch plus 1 inch times 3. So that should be 1 yard, 7 inches. Okay. I'm going to mix up my operators a little. 11 inch minus 1 is 30 inches is 2 feet, 6 inches. Is that right? Yeah. And let's just add a divide in here just to make sure that is not screwed up somehow. 12 divided by 4 is 3, plus 2 is 5, so that should be 10. All right. Boop. Okay. Operators missing between values. 12/4. That looks, whoops. That looks right. Somehow I have more parens or something. Why is that? Operators missing between values is you got to the end of the stack and you didn't have anything, you weren't totally cleaned off. These balance, right? Okay. Let's work our way from the inside. So let's take this parend and this parend. Doesn't it like a single number within parens? Ooh, that's a possibility. Yeah. Will it tolerate that? Well, wait, what, TBDs? Error missing value between operators. Yeah, I guess that one worked okay. But I thought I saw TBDs go by here, which would mean we don't have something implemented. Yeah. TBD. Did I not get these hooked up? Did I only hook up left parent and not right parent? No. TBD. Who uses that? Right. Right. Good. Entry equals TBD. Okay, key. Somehow. Okay, does our content view test. What about content view? No. Is it keypad? Where's my left and right parent? Okay. Okay, those look correct to me. Errors. TBD. Two times. I use times, right? Have I? Yeah. 2 times left parens, 3 times 4 plus 2. That just seems okay. Did I not hook up some others? Oh, divide. I got to use colons. Because we've got 2 divide operators. Yeah, the 2 with the slashes are the ones that failed. Okay. Remember, we have minus colon where they're overlaid, and then we also have slash. I'm reserving slash to work with entries. I don't know if it'll be confusing. I think both these equal 10. Okay, let's see. Maybe how to do the other one different or something. I don't know. All right. Add parentheses, but not with enough error checking. Okay. So I don't know how much to do in 4 minutes here, and I'm kind of done for the week. So I guess I don't know if it makes sense to do this down here. I'll put in a couple of test cases that are going to fail, and then we can pick up there on Monday. All right. The error, one error is too many left parens. Okay, we'll just take the simplest one. Left parent equals okay, and then the error is missing right parenthesis. Maybe I should just say that. Missing right parenthesis. Okay, this will not fail. Of course, it probably won't run with Xcode. There's a new version coming. Okay, that's good. Yeah. And that's kind of what we expect in expression. All right, so a left parend, you get to the end, and you've processed everything, and we've got a left parenthesis on the stack still. Let's see where this is coming from. Evaluate at least. Oh, I think at the end we call evaluate at least. This should probably be 1. Yeah, I think this should be 1, and if operators.count is not equal 0, then there's an error. Yeah, it definitely should be an error to start with the right parend. I think that one I expect to crash on the pop because that's doing its thing. But let's return missing right parend. Is that the place that would happen? I'm not sure I'm catching all my variations here. And I was just going to type the test in and not do this, but let's catch that other test while we're talking about it. Too many right parens. We'll start with a right. And I guess we're missing left paren. Okay. And that should fail. And the check there. Okay, yeah, that I kind of expect. And evaluate. Right. So right paren says, I assume you're going to have, I'm going to evaluate everything up to the left parenthesis, and then it just hard codes a pop. All right, so that'll give us a place to start on Monday. We'll just have to make sure that what you, that the stack is not empty, and what you pop better be a left parenthesis, or there's a problem. Okay, thanks for joining. I'm off tomorrow, so we'll be back Monday, 2 to 4:30 Eastern or 6 to 8:30 p.m. UTC. And I'm happy we got that negation done, and kind of, got the first cut of the parentheses working, even if the error cases aren't quite there yet. But we'll get there. And I think we'll make a few more tests for unbalanced parentheses and just make sure we, it's not just checking the case for the bottom of the stack or something. All right. Take care and thank you. Bye-bye.